In traditional networks, we have three main ways of tracking where clients are within the network. We have CAM tables, routing tables, and ARP tables. However, ACI changes the game a little bit. And so we actually have three new tables that we need to study. We have the local station table, the global station table, as well as the Spine Proxy. Without diving too deep, we want to take a look at what a traditional network architecture looks like and how it forwards traffic. So let's say we have a similar architecture to ACI, except again, this isn't ACI, this is traditional networking. And so we have two hosts here connected to two different switches. And the way that we do traffic forwarding is I'm going to send this packet out with a destination IP of, we'll call it B here, host A and host B. And the destination MAC address, if it's layer 2, it would be B itself. However, in the case that B is on a different subnet and it needs to be routed, that destination MAC would be switch 1. Here we'll call it S1. Assuming, of course, that switch 1 is its default gateway. Now, regardless of whether it's layer 2 or layer 3, we follow the same philosophy, which is that we forward the packet and we hope. We hope that switch, let's call this switch 3, we hope that switch 3 knows that host B lives out switch 2. So we're hoping that S3 can get us to the destination. Now, as you can imagine, ACI does things a little bit differently. So instead of some kind of forwarding and hoping type of mechanism, the switch itself, let's call this now leaf 1 and leaf 2, the switch itself is responsible for getting the traffic to its destination. In other words, leaf 1 is going to receive the traffic from our host A down here, host B attached to leaf number 2, and then it will encapsulate it into VXLAN and send it straight to the appropriate switch in the fabric. And keep in mind, we might have 100 leaf switches. So the idea here is regardless of where in the fabric it is, leaf 1 knows where host B is. How does that happen? This brings us to a very important concept in understanding the traffic flow within ACI, and that is that there are no unknown hosts within the fabric. So we know where everything is in the data center, whether it's a virtual machine or physical machine, doesn't matter, ACI knows where it lives. And it's not just part of the fabric. Keep in mind in traditional networks, if a switch 1, let's say just switch 1 down here, learns about this MAC address A living off of it, that switch 2 has no idea where A is. And switch 2 has no desire to reach out and find out where A lives. It will learn where A lives when that traffic shows up on switch 2. But that's not going to happen in an ACI fabric. So let's go back to ACI here. We'll rename these switches to be leaves. So we have leaf 1 and leaf 2. And so what leaf 1 is going to do is it's going to build two separate tables as this traffic comes online. First of all, it's going to have the local station table. This would be for directly attached hosts, meaning that, okay, so in our example here, MAC address A, host A, comes online. So we want to store not only the MAC address for A, we also want to store the IP address for A. So now leaf 1 knows where host A is, but nobody else in the fabric does, and that's not okay. So what we do is we report this connection to the spines. And the spines are going to add to their proxy, so the spine proxy is going to contain all of these connections. So we're going to track, okay, so host A lives on leaf 1. We don't need to know which port it's connected on. We just need to know which leaf in the environment has it. Whereas the local state table does actually track, let's say that's Ethernet 1/1, it's going to track exactly which interface that MAC address and IP address lives out. Meanwhile, let's say we have host B living on leaf 2. So we'll have MAC address B, IP address B. I guess we didn't really clarify that. IP address A on the left. There we go. So now both hosts have MAC addresses and IP addresses. And leaf 2 is going to do the same thing. It's going to restore it in its local state table, and it will report it to the Spine Proxy. Now back to leaf 1 for a moment. We mentioned earlier that leaf 1 needs to know where host B is, but it doesn't know that yet. And the spines don't proactively send that information down. So in a fashion that's similar to traditional networking, once MAC address B shows up on leaf 1 in some fashion, we're going to store that within what we call the global station table. And every leaf switch has a GST, just like it has an LST, but it's for remote hosts, remotely attached. And so we're going to only store the information that we need. So in this case, let's say that it's a layer 2 connection. What that means is if it's layer 2 connection, we will store MAC address B. But in the case that this connection was actually a layer 3 routed connection, so in other words, IP B is on a different subnet than IP A, then for layer 3 connections like this, we will actually store the IP address. But we're only going to store one or the other, unlike the local state table where we want to store both. So now that leaf 1 knows where host B lives, we can take the packet that comes ingress on our interface, and leaf 1 can send it straight to leaf 2. Yes, it has to bounce off one of the spines, but really it's tunneled via VXLAN. And so the source IP is itself, and the destination IP is leaf 2. And by sending it directly to the leaf to which host B is attached, we know it's going to end up in the right location. Now what if leaf 1 gets this packet before its global station table has been populated with the location of host B? Well, that's what the spine proxy is for. In that case, rather than sending the destination to another leaf switch, it's going to send a VXLAN tunneled packet up to one of the spine proxy addresses. So the destination IP will be now the spine proxy address. That lands with the spine because it has all of the information for every host inside the entire fabric. It knows exactly where it lives and it can send it down. Now once the spine proxy has done its thing, leaf 2 and leaf 1 will form that original connection and be able to send its traffic straight to each other without having to get redirected through the spine proxy. With ACI, we no longer learn where hosts are in the network in the same way that we used to. Instead, we have the local station table, which stores all the IP and MAC information for hosts that are directly attached to our leaf. Then we have the global station table, which has the same information, but really will only store either the IP address or the MAC address for hosts that are attached to other leaves in the fabric. Finally, we have the spine proxy. If we don't know where a host is, when there's nothing in our global station table for the destination, we will send it to the spine proxy and allow it, the spine, to send that traffic where it needs to go. I hope this has been informative for you, and I'd like to thank you for viewing.